So for this problem, I'm working on determining the flip-flop control equations dA and dB so that we can implement this state diagram. Okay, so we have a key here, so we know what QA and QB are defined to be, and based on the input X, we end up with this state diagram. So from here, what we do is we decide on an order of the variables. I'm going to use this order, QA, QB, X. All right, and then we come up with, based on the state diagram, the next state equations or outputs. So we put in all the input combinations as before. And based on the state diagram, we look at what are the next state equations. So on, for example, a 0, 0, on a 0, I go to 0, 1. So this is QA plus and QB plus next states. I'm going to put a little more space there. All right, then on 0, 0, on a 1, I circle back to 0, 0. From 0, 1, on a 0, I circle back to 0, 1. From 0, 1, on a 1, I go to 1, 0. From 1, 0, on a 0, I circle back to 1, 0. From 1, 0, on a 1, I go to 1, 1. And finally, for the last state, 1, 1 on a 0, I go to 0, 0. 1, 1 on a 1, I go to 0, 1. Okay, so that lets me come up with a minterm list. Okay, so we could write down the minterms. 0, 1, 2, 3, 4, 5, 6, 7. And for dA, I could write down the Carnot map. The order matters because I've decided on the most significant bit being QA. And so then QB and X would be next. I know how to label the minterms. Okay, and I'm going to copy this. And relabel this one as B. Okay, so minterm 0, to put down dA, remember dA is QA plus. Okay, so I'm looking for minterms 3, 4, 5, 3, 4, and 5. Okay, for B, I'm getting minterm 0, 2, 5, and 7. Okay, so from there, I can just do the circlings for the Carnot map. All right, so I'll change the pen color to red for this one. So I have this circling, and that gives me the flip-flop control equation for dA, reading the Carnot map. Here's QA, QB, and X. Reading the Carnot map, I see QA, QB bar. We span X, so X drops out. And then OR that with QA bar, QB, X. So there's dA. All right, for dB, we have this circling, this grouping of 2, and this grouping of 2. I can label the Carnot map. Here's QA, QB, and X. All right, so this upper grouping of 2, that's in QA bar. It spans QB, so QB drops out. Then I have X bar. And then for the bottom circling of 2, I'm in QA. And then QB is spanned, so that drops out, and then I just get X. So these are the flip-flop control equations that would implement this state diagram. Okay.